So given the head of a linked list, we need to reverse the linked list and return the new head, right? So given this linked list, we just need to reverse it and return. So first approach is using the iterative method that takes O of n time and O of n space. So first I'll be going through that. So the idea is to reverse the linked list by changing the direction of links using 3 pointers. We will have 3 pointers: previous, current, and next. And at each step, point the current node to its previous node, and then move all the 3 pointers forward until the list has been fully reversed. So you might not have understood the approach here. So let me show you using this example, right? So first we have this linked list, right? Our aim is to reverse this whole linked list. So what we'll do is we'll maintain 3 pointers: previous, next, and null. Previous is equal to null, next is equal to null, and current is equal to head, right? So these are the 3 pointers: current is equal to head, previous is equal to null, and next is equal to null, right? So once we have maintained these 3 pointers, what we'll do is we would store the next node as current dot next. So next is current dot next. Then reverse the link. So how we reverse the link? Current dot next. That is current's next. This was the link that we had. Current's next. Now we cross this out. Current's next would now point to previous, which was null, right? Previous. Then move both the pointers one step ahead. That is previous is equal to current. So now previous is pointing to current, and current would be pointing to next. And then again we iterate, since it is an iterative algorithm. We move next to current's next. So previous comes here, current comes here, and next comes here. This link has been established, right? Now what we'll do again, current's next, we point to previous, right? Then move both the pointers one step ahead. That is previous is next. Previous next is current, and current move to next. Current is current dot next. So we move it to here. And similarly, the algorithm keeps on running, and you see the links are they are reversing themselves. That is, they are linking themselves to the previous pointer, right? That is how we are reversing each and every node. And you can see here, once next reaches null, right? That is the point where when current reaches null, that is the point where we set the head as previous. This is the new head, right? This is head previous. So you see 4, 3, 2, 1. Now the linked list has become reversed, right? So that is our answer. You can see in the next slide. This has the new reverse linked list. So it was a very simple algorithm, but it is quite difficult to think of it if you're just a beginner. So let me just go through the step-by-step implementation. We initialize 3 pointers: previous as null, current as head, and the next as null. Iterate through the linked list, and in a while loop, we do the following: store the next node, that is next is current dot next, then update the next pointer of current to previous, current dot next is previous, then update the previous as current and current as next. Previous is equal to current and current as next, right? So we are updating the 2 pointers. So let's go through the code here. This is reverse list function. First we have current initialized to head, previous as null, and next is also null initially. Traverse all the nodes of linked list till the time current is not equal to null, right? As you saw in the algorithm, while current is not equal to the null pointer, store the next, that is next is equal to current's next. Then reverse the current node's next pointer, that is current next points to the previous, right? So let us say I'll make the diagram here. Let us say this is the linked list we have, right? This is the linked list. For simplicity, I'm just taking 3 nodes. We have previous, which is pointing to null. We have current, and we have the next node, the next pointer, right? So what we do is, while current is not equal to null, we check current is head, current is not equal to null, so we can go into the while loop, store the next, that is next is current dot next, then reverse the current node's next pointer, that is current's next points to null, right? That is previous initially is null. Then move the pointers one position ahead, that is now previous points to current. So this it does not point to null anymore, and current points to next, right? So current comes here, this is also done. So now next we check again, while current is not equal to null. So current is not equal to null, it is the second node here. So next is equal to current's next. So next also comes here. Now this current's next, that is this link, now changes to the previous link, right? So it comes here, and previous is now again set to current. So now current is here, and current is moved to next. So current becomes here. Now next moves to current's next, and current is not equal to null. So now this is current. So current's next now again goes to previous, right? And previous goes to current, and current goes to the next pointer. Now current is equal to null. So we come out of the while loop, and you can see we return previous because previous is now the new head, and you can see the links have all been reversed, and it has become a completely reversed linked list. So that is how we run this algorithm. Now alternative approach is using recursion method, that is, it takes O of n time and O of n space. So the idea is to use recursion to reach the last node of the list, which becomes a new head after reversal. As the recursion starts returning, each node makes its next node point back to itself, effectively reversing the links one by one until the entire list is reversed. So update the next pointer of node 2 with head, update the next pointer of head to null. So you see we have this. Let me show you exactly how it's running. So we call the recursive function with node 1 as the head of linked list, and this is the call stack. So rev 1 we put, then rev 2 it calls, then rev 3 again calls recursively, then rev 4, and next we have basically we return, since node 4 is the last node of the linked list, so return it as a reverse list. So return is as the reverse list. Now this is the head. Now update the next pointer of node 4 with the head. So next pointer of node 4 with head we updated, and update the next pointer of head to null. Right, this points to null. When once we remove ref3 from the call stack, then again update the next pointer of head of node 3 with head, and update the next pointer of this head, that is 2's head. So 2's next is null. Similarly, we do it with 1, right, and you can see it has been reversed. So how this recursion works is basically if head is first we check put checks if head is null or head of next is null, then we return head, right? Because if head is null, then we have to return null only, right? There would be no linked list coming in picture. And if heads next is null, that means we have only one node in the linked list. So reversing one node is actually the same as saying we have the same linked list, right? Because we cannot reverse this linked list. This is only a singular node. Then reverse the rest of the linked list and put the first element at the end. So we are calling the recursive function node star rest is reverse list heads next. Then make the current head as the last node of the remaining list. So heads next dot next is head, and then update the next of the current head to null that we did. Heads next is null, and we return rest. So that is another approach. And another approach is using stack. So I'll put the link in the description. You can go through it, right? So that's it about the video.